नमस्कार, आदाब, सत श्री अकाल. Today we will discuss several problems on Favorski rearrangement. In last video, we were discussing Favorski rearrangement and quasi-Favorski rearrangement. And today we will discuss problem on Favorski rearrangement. And all these problems are frequently encountered in CSIR, NET, GET, etc. examination. So, let us recall what is Favorski rearrangement. When alpha hydroketone is treated with strong base, ester is formed. If we use sodium methoxide, then ester is formed, and if we use hydroxide base, acid is formed. But most general, ester is formed, and we use sodium ethoxide. Okay? It is HH R1 R2 X R. It is living group. X is living group. Okay? And it may be fluoro, bromo, iodine, this. This. Till now, we know that X should be chlorine, bromine, iodine, because chlorine, bromine, iodine are better living group. But this bromine here, this unit, or actually it is better living group, it is also better living group. Examples of these two will be discussed after few minutes. Okay? Here you are taking ethoxide ion. If ethoxide ion is taken, the solvent ethyl alcohol we take. And if methoxide ion, sodium methoxide is taken, solvent methyl alcohol is used. Now here it is alpha carbon, means it is alpha hydrogen, it is alpha hydrogen. First of all, we have to see which hydrogen is extracted by this base. If this hydrogen is extracted, minus charge will be here, and this minus charge is in conjugation with this pi bond. These two alkyl group, of course, these two R1, R2 will form electron pair, and this results in increase of negative charge here, but it is resonance stabilized because it is in conjugation with this pi bond. Okay? Now if this hydrogen is extracted, negative charge will be here. It is also in conjugation with this pi bond, but this X, chlorine, bromine, iodine, it is electron attracting group. It will decrease the negative charge, so it is not more stabilized. It is not stabilized by resonance. So this hydrogen will be extracted, and it is R1, you will get R2, minus charge will be here, minus charge will be here, C double bond O, X R, X R, H is here, H, okay. Now this will attack here and X will be eliminated, X will be released as X minus. So you will get C double bond O, C R1 R2, C H R, C H R. Okay. This is the situation. This is 3-membered ring you get. Now, ethoxide ion will attack at this carbon and you will get R1, R2, RH, C, O minus, OC2H5. Okay. Now, this will come back, this will come back. Then question arises whether this bond will break or this bond will break. If this bond breaks in this fashion, minus charge will be here and this minus charge will be intensified by these two R1. It leads to instability. So, this bond is not broken, rather this bond breaks in this fashion. Okay. Now this bond is broken, so you get C this. We write first this C R H and minus is here. It is attached with this C R1 R2. This is attached with this C double bond O OC2H5. This is the situation. Now from the ethyl alcohol, from the solvent, this H plus will come here, leading to this RCH2, CR1, R2, C double bond O, OC2H5. This ester is formed. This is all about mechanism, just we recalled here. Now we will discuss several problems on Favorski rearrangement. It is first. Okay. Cyclohexanon and here Br. This is alpha carbon and this bromine is not directly attached to this alpha carbon. So you cannot say it as alpha hydroketon. It is not alpha hydroketon. And yet it gives Favorski rearrangement. This whole is not released, but this is leaving group. This bromine is released from here easily. How? Here the question is, you are using sodium methoxide in presence of solvent methanol. So hydrogen from here is extracted. This is actually question. Double bond O, minus will be here. Here double bond Br. Now it will attack here, it will come here, and this bromine is eliminated. And okay, right here, double bond O, this double bond is here. Br is eliminated as Br minus. It is a situation you get. Okay. Now, methoxide ion will attack here in this fashion, and you are getting here this O minus OMe. This you are getting this. Now it comes back. Then question arises whether this bond will break or this bond will break. Friends, you are suggested that you should do from both sides. If this bond breaks, what will happen? Right here as this. This bond is broken. So, it C double bond O, OMe, and minus charge will be here, this. Okay? Clear? And suppose this bond, suppose it is path A and it is path B. It is A, it is B. Now, this bond breaks, suppose. This C double bond O, OMe, and situation is this, minus charge is here. Friend, this minus charge is not in conjugation with this, and this minus charge is in conjugation with this. So, it will be minus and it will be negative. So, from methanol, H plus will come here and H plus will come here. And both of these are produced. Both of these are produced. But it is measured and it is minor. One thing I want to show you. In CSIR net exam, one upon time, this question had been asked, but out of 4 options, only this product had been given, minor, and this was not in option, and the remaining 3 options are not of our interest. So, there, this answer, this option is correct. You should take this option. Okay? So, you are advised to go through both the paths and see what happens, which species is more stable. Friend, one thing also I want to say that if such type of living group is here, then what will happen? And what will happen here? It will attack in this fashion, it will come here and it will come here. You will get O minus. O minus, and next thing, it will be converted into OH. It is another thing, but I want to say that this bond will break in this fashion, means it is also a living group like chlorobromo iodide. Okay? Now, we will proceed to next problem. Second problem is this. It is cyclohexanon and it is chloro group. It is tertiary butyl group. And both the groups are upside. From here we say it is wedge. Wedge means up and it is dash. Dash means down. So, and it is treated with sodium ethoxide ETONA and solvent is ETOH. What is product? It was the question in an examination. First of all, we should write in chair form. This parallel, this. Cyclohexanon. Double bond is here. Okay, cyclohexanon and chlorine and this tertiary butyl group are 1, 2, 3, 1, 3 relation. It is 1, it is 3. Suppose it is up, chlorine up and it is down, and 1, 2, 3. It is up and it is down. Okay, and actually you should test that if it is planar and these two groups are in upside, then it will be cis. And it is one thing, first of all, you should have knowledge of cis trans. Cis means same side, trans means opposite side. A separate video had been uploaded in past. You should go there. Okay? It is 1. Suppose it is 1, it is 3. And these two are axial. Then 1A, 3A, same side, upside, it will be cis. And 1A and 3E will be trans. And since this is very bulky group, tertiary butyl, therefore it is always situated in equatorial position. And if it is equatorial, it will be also equatorial. If 1A, 3A is cis, then 1E and 3E will also be cis. And these two are in same side, upside, and so it is cis. And that's why we have written this molecule as cis. Okay. Now, if it is treated with ETONA, ethoxide ion, better to write ethoxide ion, it is keto group, it is halo group. Okay. Then H minus hydrogen from here is abstracted by this base. Okay. And now it is here there is one hydrogen. Okay. It is sigma bond. It is sigma orbital. Therefore it will be sigma star. Sigma star will be here. And this lone pair of electron, this minus charge will be in and bonding orbital, and it is near to this, so it will be connected to this easily. One aspect, one idea. Second idea, this is leading group, this and this. These two are anti-periplanar. Friends, what is anti-periplanar? Let us understand. Elimination. Suppose it is carbon, it is carbon. We are talking about ethyl chloride. We are talking about ethyl chloride. Then this leading group and this hydrogen, chlorine and hydrogen. These two atoms are living atoms here, and these two are in transposition with respect to each other. This hydrogen is eliminated, then there will be two electrons here in bonding orbitals, and it is sigma, these two electrons are in sigma orbital, and here is sigma star, it is sigma star, and it is blank. And these two electrons are near to this, and it is easily connected to this sigma star. So elimination will take place. Minus SCl is eliminated. Chloride ion is eliminated. And here H plus is eliminated. Overall we say that HCl is eliminated, resulting to double bond. Friends, suppose if you are looking, it is carbon, there is single bond. Carbon, single bond. And if chlorine is here and it is, suppose hydrogen is here, the angle angle will be 90 degree if you are taking in this fashion. If you are taking in this fashion, then it is carbon single bond, and this carbon chlorine bond and it is carbon hydrogen bond are anti-periplanar, means dihedral angle is 180 degree. If dihedral angle is 180 degree, it is called anti-periplanar. Anti-periplanar. So here friend, this is living group, this bond and this bond, although this bond doesn't break, actually this carbon hydrogen breaks. Even then we say this bond and this bond are anti-periplanar, so atoms attached with this bond will be near to this sigma star. So elimination will take place. Okay? Elimination will take place. It will attack in this pattern and it is released in this pattern. And so you will get parallel, this. Double bond O, this, and here this. Okay, this is the situation. Okay, now ethoxide ion will attack in this pattern. Parallel, this. O minus OET. Okay? This. Now, it will come back. Then question arises whether this bond will break or this bond will break. If minus will be here, 1, 2, 3, tributyl will be in 1, 3 position. It is 1, it is 3. If minus charge will, and ester group will be here. If minus charge will be here, ester group will be here, and it has relation with tributyl 1, 2, 3, 1, 3 relation. So product will be same if you proceed, if you break either of these two bonds. So what are you getting? We write here what are you getting? This. Five-member ring. This. And ester group will be COOET. Ester group will be here. And minus charge will be here. Okay? This bond is breaking. So, suppose this bond is breaking. This bond is breaking. C double bond OET. Okay? It is minus. Now, hydrogen from ethanol, H plus from ethanol will come here. Okay? Then the product is this. Now, you should write it in this fashion. Okay? It is pentagon. It is up 1, 2, 1, 2, 3. 1, 2, 3. It is up. Okay? So it is tertiary butyl group. And this is up. Ester group is in upside. So you should write in this pattern. C double O E T. Means you are getting cis product. Okay? It was the second problem. Now we will discuss third one. It is hexagon, cyclohexanone. It is chloro 1, 2, 3. It is tertiary butyl group. And it is allowed to react with sodium methoxide in presence of ethanol. Okay? First of all, we have to write it in chair form. Okay? It is double bond O and this chlorine is downside. So chlorine will be here and 1, 2, 3. It is upside. So upside. It is downside. Upside. It is tertiary butyl group. Okay? Now, if you are taking ethoxide ion, it will extract this hydrogen leading to this. Okay? And this bond and this bond, look at these two bonds. These two are perpendicular. These two bonds are not anti-periplanar. So, reaction will not take place. Reaction नहीं होगा. Reaction will not take place. It was the third problem. Now, let us see fourth one. Number 4. Cyclohexane. It is the ketone and it is the CH2Cl. Suppose we take here, it will look better. C double bond O. C double bond O. C double bond O and CH2, it is alpha carbon. CS2Cl, and this. Upside 1, 2, 3, upside tertiary, okay, and it is treated with ethoxide and ethanol. What will happen? Write it in chair form. This and this. It is up. 1, 1, 2, 3. 1, 2, 3. It is in this fashion. 1, 2, 3. Okay? And it is up. This is up. C double bond O, CS2, Cl. Okay? Now base is taken ETO minus. Then what will happen? What will happen? It is keto group. Hydrogen is extracted from here. Okay? This is produced. Then what will happen? This will attack at this carbon and this bond will break in this fashion. And you will get this. C double bond O, CS2, this. Now, ethoxide ion will attack here and you will get this. When it will come back, this bond may break, this bond may break. If this bond breaks, negative charge will be here. If this bond will break, negative charge will be here. If negative charge will be here, then it is attached with this alkyl, this alkyl, this alkyl, 3 alkyl, which will pump the electron and electron density will be greater here. So it leads instability. If negative charge will be here, it is better, it is stable. It is not unstable. So you will get this one. You will get this double bond O and CS2 minus. And then hydrogen from H plus from solvent will come here and it is methyl. It is methyl. And this is your final product, and now you have to write it in this fashion. It is hexagon, okay? It is upside 1, 2, 3. 1, it is upside, okay? This 1, 2, 3. 1, 2, 3. Okay? It is up, it is down. Okay, friend? Here, how we should write? Okay? It is up. Here, it is up, it is down. 1, 2, 3. It is down. So it is methyl. It is up. It is ester. COOET. This will be your product. Now we will proceed to fifth problem. Fifth one is this. Hexagon, it is upside, tertiary 1, 2, 3. Suppose it is downside C double bond O CH2Cl, and it is allowed to react with ethoxide ion and ethanol. First of all, we should write it in chair form. 1, 3, 1, 2, 3. It is upside. It is tertiary group, and it is downside, up, down. C double bond O CH2Cl. Okay? Downside. When it is allowed to react with a oxide ion, it will extract hydrogen from here. Hydrogen, now here, friend, if hydrogen is extracted from here, it is carbonyl group and alpha carbon is this. Okay, hydrogen will be extracted from here, so it is minus. Now it is attacked on this carbon, and this chlorine is released as Cr minus. Then you will get this one, this, and here C double bond O CH2. Okay. Now ethoxide will attack here. Then you will get this. If it will come back, then this bond may break. If this bond breaks, negative charge will be here. If this bond breaks, negative charge will be here. And actually this bond breaks, you should check here yourself. Then your result is this. Double bond is here, negative charge will be here. Now proton from ethanol is taken and it is converted as CH3. It is up, it is down. Now we should learn to write it into this form. This. It is upside, this tertiary group. 1, 2, 3. 1, 2, 3. Okay? Methyl is up. Methyl, it is CH3, and this ester is down. This ester is down. C double O E T. This is your product. Friends, hope you will like my lecture, and if like, must share to your friends. Thank you very much.